Hello, everyone. My name is Kelly Dudley with the New Center. I'd like to welcome you to today's webinar, ABCs of Carbon Neutral Concrete, LCAs, EPDs, PCRs. We're glad you could join us. A video recording and PDF of the presentation you're about to see will be uploaded to the new website, newconcrete.org, following today's webinar. Because attendees are in listen mode only. Because we are recording the webinar today, we'll be taking questions via email at info@newconcrete.org. The ideas expressed in the following presentation are those of the speaker and do not necessarily reflect the views of the New Center, ACI, or its committees. As with all concrete mixtures, trial batches should be performed to verify concrete properties. Results may vary due to a variety of circumstances, including temperature and mixture components, among other things. You should consult your materials, cement, and concrete professionals for assistance regarding concrete production or placement. Nothing contained herein shall be considered or construed as a warranty or guarantee, either expressed or implied, including any warranty of fitness for a particular purpose. An abstract of today's webinar is shown on the screen and is also listed on the new website with the webinar series information. Now I'd like to introduce our speaker. Mr. Frank currently serves as the Executive Director of the New Center. He previously served as new Director of Validation and ACI Senior Program Developer, and prior to that was the Principal Consultant for Dean Frank Associates, LLC, and Director of Quality Sustainability Programs at the Precast Prestressed Concrete Institute, and Director of Technical Services at the National Precast Concrete Association. He has been an active member of related industry committees, including ACI, ASTM International, PCI, and FIB for over 20 years. He obtained his MS degree in structural engineering from the University of Colorado at Boulder and is a registered professional engineer in Colorado and Indiana. And now I'll hand the presentation off to Dean Frank to get started. Thank you.
Thank you, Kelly. Can you hear me okay?
Everything sounds great, Dean.
Great. Thank you so much. And
welcome.
Welcome, everyone. Today's topic, ABCs of Carbon Neutral Concrete, LCAs, EPDs, and PCRs. So the reason why we came up with this, we know it might be a little bit basic for some folks out there, but we also know that with the intricacies of these items and tools, some people don't exactly know how they work or what they are exactly. So we're going to start off kind of with some of the basics, and actually very basic. We'll start off with what is carbon neutrality. So what do we mean when we say carbon neutrality? Well, when we talk about carbon, we're really talking about carbon from CO2 or carbon dioxide in the atmosphere. Carbon neutral means there's a neutral effect of CO2 in the atmosphere. Any emissions being released must be balanced by an equal amount of CO2 being removed from the atmosphere, either through carbon sequestration, offsets, or carbon sinks. Those carbon sinks are soil, the forests, oceans, which have a finite amount of ability to sequester carbon. We also know that concrete itself actually sequesters carbon over time through carbonation. So carbon reduction is necessary for us to reach neutrality. Carbon offsetting from emissions made from one sector or another and reducing them elsewhere is what we're talking about. That includes renewable energy, energy efficiency, and lower carbon technologies. It's important to keep in mind here that our goal is net zero or zero emissions in the long term, and potentially even negative emissions, which apparently is already happening in some places in Europe. However, industrialized processes, we all know today, have some work to do to get there. So in the meantime, we focus on emission reduction and carbon neutrality. So here's an illustration that kind of talks about, the progression that we need to take in order to reach net zero for ordinary Portland cement. So the top line is, we're somewhere between the top illustration and the middle, where we're replacing energy from fossil fuels with clean energy. The red line at the very top is our CO2 emissions that we need to balance somehow. So in many cases, that's being balanced through carbon sequestration or offsets, with the ultimate goal again at the bottom being net zero, where we don't need those offsets and carbon sequestration. We've had many people ask, well, why are we focusing just on carbon? We know there's a lot more to sustainability than just global warming, right? You know, the three pillars of sustainability: environmental, social, and economic factors all play into sustainability. But we also know that concrete really shines in many areas related to sustainability, such as resilience, thermal mass, or durability. Global warming is affecting all of us. Everyone on the planet's experiencing the effects. So it's not something that we can ignore. But we also know that the concrete industry is in an excellent position to make improvements upon one area that tends to receive the most negative attention, which is the CO2 emissions. We also know that we can measure CO2 associated with concrete. And we can't improve something without being able to measure it first. So this is where we're focusing. So talk about some of these generalized definitions. What is carbon neutral? It's basically a neutral effect of CO2 in the atmosphere. Net zero, neutral effect on all greenhouse gases on the atmosphere. Global warming potential is a way to compare the long-term effect of different gases. So what are we talking about? You know, which gases are we talking about? So you might see shorthand for greenhouse gases, GHG. Greenhouse gas, the primary one that we focus on is carbon dioxide. You can see from the illustration here, 75% of the greenhouse gas emissions from 2020, 79% of that was carbon dioxide. CO2 enters the atmosphere through burning fossil fuels, solid waste, trees, and other biological materials. It's also a result of some chemical reactions, including the manufacture of cement used in concrete. Carbon dioxide is removed from the atmospheres when it is absorbed by plants and a part of a biological carbon cycle. Another greenhouse gas that we talk about is methane. Methane is emitted through the production and transport of coal, natural gas, and oil. Methane emissions also result from livestock and other agricultural products, and decay of organic waste, municipal solid waste, landfills, etc. Nitrous oxide is emitted during agricultural and land use, industrial activities, combustion of fossil fuels, and solid waste. It is also emitted during treatment of wastewater. And finally, the fluorinated gases, those are your hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluorides. It's a mouthful, but those ones are very powerful greenhouse gases. They're emitted from household, commercial, and industrial applications. Next acronym that we talk about is global warming potential, or GWP. It's a measure of how much energy the emissions of 1 ton of gas will absorb over a given period of time relative to the emissions of 1 ton of carbon dioxide. So we talk about carbon dioxide equivalent, or CO2 equivalents, which is a measurement used to normalize the emissions from various greenhouse gases. So some of those gases are much more powerful in absorbing heat as compared to CO2. Now let's get to the main subject of today's webinar. We'll talk about the common tools and their acronyms and how they relate to sustainability, or more specifically carbon neutrality. So LCA, you'll hear that acronym a lot, stands for life cycle assessment. PCR, or product category rule, and EPD, environmental product declaration. It's really important to note that EPDs rely on both an LCA and a PCR. So I'll get into that in a few moments here. We'll start off with talking about what an LCA is. Basically, an LCA is a standardized method for examining a broad range of environmental impacts associated with a process or a product or even a project, such as a building, over its complete life cycle. It's governed by the ISO standard 14044, Environmental Management Lifecycle Assessment Requirements and Guidelines. So LCA is a form of life cycle analysis, which can be broken down into two different types. Basically life cycle cost analysis, which is a monetary accounting or economic, and then LCA, which is what we're talking about today, life cycle assessment, which is an environmental accounting. So LCA evaluates the full environmental impact or a process or a product or even a project, like I said. It's a full assessment of all associated impacts rather than a single criterion, which is what new is basically focusing on, greenhouse gas emissions, but that is part of an LCA. LCAs are supported by science. They're not intended to be subjective. So credible LCA requires several items. First and foremost, credible data, whether that's real life data from a manufacturer, such as a concrete plant or a precast concrete plant, cement manufacturer, or if there's also life cycle inventory databases available that have information available to use in an LCA. Also needs to be based on credible processes. Fortunately, we have the ISO standards, the international accepted standards for LCA. Also requires transparency. LCA does require an external review team, which are subject matter experts, and also knowledgeable consultants. Those are the folks that actually write the LCA. They do take a conservative approach to the analysis, especially when the LCA is being used as a comparative analysis. If comparing one project to another and one material to another, the requirements make you be very conservative with it. So what does an LCA include? Well, the environmental effects due to raw material extraction and fuels used, the manufacture of the components, whatever they may be, whether in the building industry, obviously it's going to be foundation, beams, columns, roofing material, windows, everything that goes into a building or an individual product, transportation of those components, assembly and construction, operation and maintenance, which today represents the biggest energy use associated with a project. But as energy efficiency increases over time, the initial upfront embodied carbon is going to become more critical. And then finally, demolition, disposal, recycling, and potentially reuse of those materials. So the boundaries in this case, when we talk about cradle to gate, you might hear that term thrown around. That's basically the first two bullets, raw material extraction, fuels used in manufacture of components. Once it's on the truck and heading out the gate, that's where the accounting stops. You might also hear cradle to grave, which is the preferred method for analysis, and that would include every one of these bullet items. So what environmental impacts are we looking at with an LCA? Well, global warming potential. Again, that's the heat absorbed by a greenhouse gas in the atmosphere as a multiple of the heat that would be absorbed by the same amount of carbon dioxide. So different gases have different global warming potentials. For example, methane has about 27 or more to 30 times the global warming potential is CO2. Acidification potential, which refers to the amount of different compounds that contribute to acid rain. eutrophication potential, which is the potential to cause over-fertilization of water and soil, which can result in increased growth of biomass. Smog creation potential, ozone depletion potential, and we also look at the primary energy consumption associated with a product or project, which can then be further broken down to energy from renewable and non-renewable sources. So the LCA process is iterative in nature, basically has 4 steps. The first one is the goal and scope, where you set the boundaries. Again, I talked about cradle to gate or cradle to grave. This is where you would set the boundaries that represent the product's environmental impact. Again, the preferred method is full life cycle, but you might find that that full life cycle might be difficult to calculate for some items, in particular, a cubic yard of concrete. So typically you'll see information that's available, especially with EPDs, for a cubic yard of concrete that's considered cradle to gate. And we'll talk again more about that in a minute. The next step is the life cycle inventory. This is where you do your environmental accounting for individual environmental flows. It's basically a huge material takeoff, and then you determine what are the emissions and materials and inflows and outflows associated with each one of those materials, and multiplied by the quantity, of course, that's being used. Life cycle impact assessment then assesses those environmental impacts and determines how those materials and emissions affect the environment. And then the interpretation phase. This is where you find the hotspots and look for other goals for the study and make sure they're summarized or assessed, whether or not in that potential LCA or further LCA in the future. So looking at the life cycle inventory, this is just a kind of a depiction as to what we're looking at. If we're looking at a building, we're looking at all the materials and energy that are used into manufacture, operation, and deconstruction of that facility. And then what are all the emissions associated with those materials, air, land, and water emissions. I know you can't read this, and I don't expect you to be able to, but this is just a kind of a depiction as to how complex this really can be. This is, a material flow process chart for cement production. And it's not even the whole thing. This is just a part of it, but it's very complex. So this analysis, is time consuming and difficult. So we do know that LCA is a good tool, but again, complicated and expensive. It does not result in a single number. Typically results in a report 50 to 100 or more pages long. And oftentimes the folks that are reading those reports find it difficult to know what the best choice is with respect to choosing the correct environmental impacts. So what we really need is something a little bit more simple. Although we do know that LCAs are good. They're a good tool for determining environmental impact and probably the best tool we've got. But again, complicated. At the end, the reports can be difficult to wade through and determine what the best choice is. A lot of practitioners are looking for something a little bit more simplified. So really what they want to use it for is to compare similar products. So what we need is something that kind of looks like a nutrition label, and that's an EPD. So we'll talk about EPDs next. So an EPD stands for Environmental Product Declaration, which is governed by ISO 14025. This is the typical one that we see being used, type 3 declaration. So these are the 3 types, but type 3 is the one that we typically look at. It's based on an LCA, and thus it's can report the full life cycle of impact of the product or project. The 14025 standard sets the standard for type 3 environmental labels. Again, it's based on LCI and LCA data, and that is governed by ISO 14040 series of standards. So there's lots of different ISO standards out there that govern all these processes. So it can be a little cumbersome and complex, but that's why we have consultants, right? So the processes require major stakeholders be involved, and also peer review. So there's make sure that what's being done is being watched over and key stakeholders are included. So again, governed by ISO 17025, or excuse me, 14025. The EPDs provide information on multiple sustainable attributes, and that information comes from an LCA. So in order for us to produce these product labels and be comparable from one similar product to another, we need what's called a product category rule. So here's our next acronym. Plenty of acronyms. So hopefully this will be a little bit more clear after today's webinar. So the PCR provides instructions as to how to conduct the LCA in order to fulfill the requirements for compiling and presenting data in the EPD. So it's kind of the go-between between the LCA and the EPD. And just for your reference, a product category is a group of products that can fulfill equivalent functions. For example, floor tiles, CMU, concrete masonry units, insulation, or concrete, or precast concrete. We'll talk about that in a minute. So PCRs are governed by their own ISO standard 21930. They're created and administered by a program operator. There's lots of different program operators out there: UL Environment, ICCES, ASTM, even NRMCA is a program operator. So there's lots out there to choose from. There's a separate PCR for each product category that is required. The PCR sets the declared or functional unit for a category. So in this case, when we're talking about concrete, we're talking the functional unit is generally set at a cubic meter or cubic yard. So again, sets the rules for the LCA, which includes the goal and scope. So which life cycle stages are we including or excluding? Again, life cycle stages are, cradle to gate versus cradle to grave. Also talks about the life cycle inventory. What are the cutoff rules? And when we talk about cutoff rules, we're basically saying, when do you stop considering information? If it's a small amount, contributes a small amount to the overall environmental impact, say somewhere between 1% and 5%. Where do you finally cut off and say, okay, we don't need to consider anything less than 1% or 3% or whatever. So the PCR sets that information up. It also talks about how the life cycle impact assessment is done, basically which assessment method and which impact categories should be considered. Also sets the rules for the EPD. So you have a standard set of rules for conducting the LCA, and then how do you present that in the EPD? It needs to be standardized. So information about the program operator, again, that's the organization that actually writes the EPD, and the verifier. It sets up the required format for the EPD label. Again, the impact categories to be listed, inventory items to list, and so forth. But how do all these things relate to each other? Because they are interrelated. So again, to produce an EPD, you've got to have an LCA. And when I'm talking about an EPD, this is a type 3 EPD. An LCA must be conducted in accordance with the PCR, and the resulting EPD must meet the rules set forth in that PCR. So both the LCA and the PCR feed into the EPD. So what are some examples? So here's an example of a product category rule for concrete. This was initially published by the Carbon Leadership Forum, and I was actually involved with that group. And gosh, that was 10 years ago. November of 2012 was when the first version was published. And then I was also involved in version 1.1 in the following year. So that is published by NSF International, and you can get a copy of that from their website. It's available for free. Another example of a PCR is the precast concrete PCR. This one was published and published by ASTM, but supported by PCI and CPCI. So you can find this on the ASTM website. I also worked with ASTM when I was at PCI to get this published. And associated with that PCR is the resulting EPD. Again, this one was published by ASTM as they were the program operator. And it's owned by PCI and CPCI, or the Canadian Precast Prestressed Concrete Institute. So here's an indication of what's reported in that EPD. So it kind of looks like a nutrition label. So hopefully this kind of gives you a better idea of what's out there. I know I went through this quickly. Some folks, this is old hat for them. Others, this is probably new. So hopefully the learning objectives have been fulfilled to some extent here for you. Basically that was to learn about existing tools and processes related to assessing environmental information related to carbon neutrality, and also learn how these tools and processes relate to and depend on each other, which they absolutely do. I'm going to take this opportunity to talk a little bit about NEW, the ACI Center of Excellence for Carbon Neutral Concrete. If you're new to NEW, this is for you. So the vision for NEW is we envision a concrete industry where all stakeholders have access to technologies and knowledge needed to effectively and safely produce and place carbon neutral concrete and concrete products in the built environment. Our mission is to collaborate globally and drive research, education, awareness, and adoption of the use of carbon neutral concrete, materials, and technologies in the built environment. Sounds like a big task, but someone's got to do it. So here's the someone's who's doing it. Here's the NEW team, myself, Dr. Andrea Schacher, Kelly, Dr. Sharika Sumatura, and Carrie Moosman. So thank you very much to my team. I'm also going to take this opportunity to talk about an upcoming webinar, NEW validation program. This is going to be a key function for the NEW Center of Excellence. And when we talk about validation, what is it? Well, it's a process for evaluating the reasonableness of the assumptions, limitations, and methods that support an environmental statement about the outcome of future activities. So that's the important part of validation. It's about future. You're predicting the outcomes, potential outcomes of a process. But also, a part of the validation process is referred to as verification. It's actually validation and verification. So verification is the process for evaluating an environmental information statement based on historical data and information to determine whether the statement is materially correct and conforms to relevant criteria. It's a mouthful, but basically you're looking backwards at historical data and make sure that it was calculated correctly. So what we're doing is we're looking for assurance in the accuracy of manufacturers' environmental claims. So look for more information from NEW about a webinar on that topic in the future. Again, we're going to be focusing heavily on validation in the future, and we feel it's a critically important topic. So thank you all for attending. Kelly, I think I'm turning it back over to you.
Yep. Thank you so much, Dean. We appreciate it. Please visit the NEW website at newconcrete.org for more information on this topic. While you're there, please check out our resources on lower carbon concrete production and placement. The website provides access to our sustainable concrete guides, frequently asked questions, webinar recordings, and more. Again, we're happy to answer any questions you may have from today's webinar. Please forward them along to info@newconcrete.org. Thank you for attending today's webinar, and please stay tuned for future new webinars. Thank you.